Welcome to the Arithmetic Zone and welcome back to our Simple Java series. As you can see in our thumbnail, today we're going to cover the wrapper and math classes. But before we get into that, I want to go into the modulus operator. If you remember earlier in the series, I went over the different operators in Java: addition, subtraction, multiplication, and division. But one operator that I didn't really cover is the mod operator. And what the modulus operator does is that it takes two numbers and it finds the remainder if you were to divide by those two numbers. So let's run this code and see what we get. And we get 1 0 1 0. And so I was checking 3 mod 2, 4 mod 2, 5 mod 2, and 6 mod 2. So what it's doing is it's doing 3 divided by 2 and it's finding the remainder. So 3 is not evenly divisible by 2. There's a remainder of 1. 4 is evenly divisible by 2. So that's why the result is 0. Same with 6, which also 6 mod 2 is 0 because there's no remainder, and 5 mod 2 is 1 because that's the remainder. And there's several uses for using the mod operator. Probably the most common is to check if a number is even or odd. All even numbers, if you were to divide them by 2, it would have a remainder of 0. So as you can see, 4 and 6, and when I did mod 2 with them, the output was 0. But all odd numbers, if you were to do mod 2 with them, then the remainder would be 1. And this is a very useful tidbit to know in Java. And of course, there's other uses of the modulus operator. You can check basically if any number is divisible by a number. So let's do let's check if numbers are divisible by 5. So I'm gonna have numbers 1 through 5, and I'm checking if they are divisible by 5. So I gotta change this 2 to a 5. And if I were to run the code, you can see that 1 divided by 5, that doesn't really work out. The remainder is 1. Same with 2. The remainder is itself. The remainder is the first number, and same for 3 and 4. But 5 is evenly divisible by 5, hence the remainder is 0. And you may notice that anytime you take a number and mod it by another number, if the first number is smaller than the second number, then the remainder is always going to be the smaller number. Now, if it's larger, or equal to, that's when things get a little different. If it's equal to, then the remainder should always be 0. If it's larger than, it could be equal to 0, or it could be equal to, the difference. And you may have to do the difference several times. So other uses beyond checking with evens and odds for modulus operators, it's useful for time, where you take the value of seconds and mod it by 60 to determine how many minutes, or determine how many leftover seconds there are, and then add the minutes. It's useful for identifying patterns, useful for calculating money, when you have pennies, nickels, dimes, quarters, dollars, all that uses the mod operator to check the leftover amount. And like all the other operations, the modulus operator has its own compound operator. So I can do that, and if I were to print out a num after using the compound operator by doing mod 2, let me just comment all this out, should get that it is equal to 0 because we took 2 and then we adjusted the value of num so that we did mod 2 once, and then 2 mod 2 is 0. So that's the result. Another useful thing you can do with the mod operator is find the digit of a number. So we're going to go into this more a little in depth later on, but for starters, let's have the number 534. If I want to print out the ones digit, which is 4, I would simply take the number and mod it by 10. And why does this work? Well, we're dividing 534 by 10, and then we're finding the remainder, which should be the ones digit. And there's other ways to get the tens digit and the hundreds digit, but we'll do that at another time. And on a final note, just like with division, you never want to do mod 0. because that's just going to cause your program to, not work. You have an arithmetic exception, division by 0. So never do mod 0. Now let's move on to looking at other classes. So I mentioned earlier that we were going to look at wrapper classes, and this is what we're looking at right now. So I mentioned the 3 primitive variable types in Java: int, double, and boolean. All 3 of these primitive types have an associating wrapper class: integer for int, double capitalized for double, and boolean capitalized for the boolean primitive data type. And what these wrapper classes allow you to do is that they basically allow you to treat primitive data as a class. So some of these wrapper classes have like their own, instance variables and their own methods, as we're going to see right here. So let's declare an object of one of these wrapper classes. So you may remember how to do this from the string video. So what you do is you take the class name, then you take your object name, let's call it A, then equals and new, and then the class name again, and then parentheses, and then your value to initialize it. So let's say 5. So, and you see that this is crossed out, and it says the constructor integer int has been deprecated since version 9 and marked for removal. And the reason why is because in older versions of Java, when you're dealing with wrapper classes, you had to like declare them this way. You had to initialize them this way. They were like almost separate from primitive data. But in newer versions of Java, they allowed it so that depending on what you do with your primitive data, if you treat it, or depending on what you do with your wrapper class, it gets treated as primitive data. So you don't have to like convert between the two. And that definitely simplifies a lot of code. But it also makes like a lot of these methods a little redundant. But we're going to see some useful methods that you could still use. But one of these not so useful methods is comparing the value between the two. So I have 2 integers, right? Value 5, value 10. I apologize for this little strike through. Can't really do anything about that. That's a project stem thing. So what if I want to know which one is greater? Well, I can use the compare to method that's associated with the integer wrapper class. So a.compare to b. So we're comparing the value of a to b. Let's see what we get. We get -1. Now that doesn't really make sense. I mean, 5 is 5 away from 10, not -1 or 1. Well, what the compare to method does is that it returns one of 3 numbers: -1, 0, or 1. -1 if the first integer is less than the second integer, which is what it did. 5 is less than 10, hence it returns -1. It turns +1 if the second integer is greater than the first integer, and it returns 0 if they're even, or not even, if they're equal. Sorry about that. So if I were to do b.compare to a, this should print out +1, and it does. And let's say I have another integer. We give it the value of 5, and I do system.out.println a.compare to c, and these two have the same value, so it prints out 0. So again, I said that this method's a little redundant because we could just use Boolean expressions with primitive data instead, and we're gonna do that in the next video. But for now, I just want to show you guys some of these little wrapper class methods. There's also a dot equals method. So system.out.println. Let me just comment this out so you don't get confused. a.compare, or no, a.equals b, and this returns a boolean to see if they are equal to each other. So a and b are obviously not equal, so it's going to return false. But what about comparing a and c? If we compare a and c, it's going to return true because they both have the value of 5. Again, redundant method because we could just use Boolean expressions. But in older versions of Java where these implicit conversions between primitive and wrapper class data were not possible, this was a necessary thing that you had to do whenever you dealt with wrapper classes. And you may be wondering, why do you even need to use wrapper classes? Well, you're going to find a use eventually when we get into array lists, which mandate you to use class data. But for now, just know that these wrapper class equivalents of primitive data do exist. So we've been dealing with the integer methods for now. Let's deal with integer values. So I'm going to comment this out. So one useful thing about the integer class is that it has one of these set values called max value. And it basically prints out the maximum possible value that an integer can be in Java, which is this number, which I believe represents 2 to the power of 31 subtracted by 1. And likewise, there is a integer dot min value. Not that. Now notice that these when I'm writing max and min value, they don't have parentheses. That's because they're not methods. These are actual values that the class holds, and I believe min value returns negative 2 to the power of 31 without the minus 1. Yeah, as you can see, this one is this one's not like, the same number as that. They're not perfect opposites of each other. And it's not just integer that has these values. Doubles also have a max and min value. So double dot max value and double dot min value, not min exponent. We print these out, and it gives us, a pretty huge number and a very, very small number that I don't actually know what exactly it equals to, but just know that that exists. You may be wondering, how come when I'm referencing max and min values, I'm using the class name and not the object name like I did here with the methods? That's because these values are static, and we're gonna talk about that more a bit later, especially once we get to the math class. But just know that any static methods and static variables, you reference the class name, and a non-static method or non-static value, you have to make an object of the class and then reference the method or variable name. The thing about static methods and variables, though, is that you don't actually have to use the class name. You could still use an object created by the class. So I can just write a, because I made a integer, and it should function exactly the same as you can see right here. And it's going to give me this yellow squiggly line. Yeah, static field should be accessed in a static way, because really there's no reason to use an object. It's preferable to just use the class name, because there's no reason to use an object. There's no reason to use a unique object if you're just going to be using a method or variable that exists for any object created by that class. On a final note, on earlier versions of Java where there was no way to convert between these two implicitly, you have to do it manually. So what you would have to do was reference an object, and then, so this is an int object, and you would have to say int value. And then likewise, same thing with doubles. Let me just make a double object real quick. So this is how you converted between primitive and wrapper class data, right? And it's just going to print the same number, 5 and 4.5. And again, these methods are mostly redundant. These are still useful though. These are still useful, so definitely keep these in mind. But I just wanted to introduce you to the concept of wrapper classes, so you don't get a headache when we get to array lists, which you need to use wrapper classes for those. Now let's talk about the math class. So let's look at the math class now. And as you can see, we already have a method here that we're going to look at, Math.abs. So math is another default class that comes automatically, when you make a Java file. And the nice thing about the math class is that pretty much all of its methods are static. So we don't have to make an object with the math class. We can just reference the class name math. So looking at the Math.abs method, I think it's pretty clear what it does, but essentially returns the absolute value of the value that's passed in it. And note how Math.abs actually has two ways to format it. You can either put an integer in it or double. And we know it's not just one double method, because these two the two first Math.abs functions, they return an int. If it was a double, it would have 5.0 in it. So we know that we can use both an int or double, and it returns the absolute value. So we have -5 and 5, returns 5 in both cases, 3.5 and -3.5, returns 3.5 in both cases. So that's the absolute value method. Pretty simple. Now let's look at the exponent method, or the power method. So in JavaScript, there was a way for you to just, easily do exponents using double asterisk signs like that. So that would be 2 to the power 3, but that doesn't exist in Java. In Java, the best way to do, exponents is to use the math class and use its pow method. So Math.pow. And if we want 2 to the power 3, we use 2 as the base and 3 is the exponent. That's what that represents. If we were to print this value out, we get 8.0 because 2 to the power 3 is 8. And note how, unlike the ABS method, which had a dedicated, integer method and a dedicated double method, this one, it just automatically converts your ints to a double, and that's why the value returned will always be a double. And if you don't like that, what you can do again is just cast that double value into an int, use it like that, and we get the value of 8 as an integer. So that worked out pretty nicely. On the flip side of the pow method, we have the square root method, and it's called Math.sqrt, and you put a double in it. So just like pow, this one only really works as a double. So if you pass an integer, it's just going to give you a double. So even if you pass in a number like 4, which square root of 4 is 2, an integer, it's going to give you 2.0 as a double. And if I pass in a number like 2, which doesn't really, which is not a perfect square, it's going to give me, this ugly decimal. It's going to end eventually because, Java has limited data, and that's like the max, amount of space a double can take right there. But that's the square root method, as you can see. But the last method we're going to look at is probably the most useful method, and also probably the most difficult to understand and the most difficult to utilize, and it's Math.random. And Math.random has no parameter, so you don't put anything in the parentheses. Now let's print this value out. Let's see what we get. Get 0.999. Wow, that's actually pretty lucky. Print it out again. I get 0.378. 0.011, 0.846. Honestly, kind of insane that I got 0.999 like first try, but if you can't tell what it does, Math.random returns a random double from 0 inclusive to 1 exclusive. So essentially, you can get any number from 0 to 0.99999, you get it. But it can't ever be 1. And yeah, this is basically the easiest way to get random data in your Java files, but in its raw form like this, Math.random is not very useful, because what's the point of getting a random, decimal? We want random integers, so, we have better control over our random numbers. So we're going to have to modify our range, and we're also going to have to cast it into an int. So let's say I want a random number from, say, 1 to 50. So the first thing I'm going to do is multiply Math.random by 50. This, this basically multiplies the range so that it basically goes up to 50, but it doesn't include 50 because the range is from 0 to 0.999, right? If I multiply 0 and 50, I get 0. But if I multiply 0.999 by 50, I get 49.9999. Not quite 50, but essentially. So, if I were to, print this now I get, actual numbers, not just 0 to 1. But it's still in a decimal form. So let's cast it into an int. Now we're taking the 0 to 49.999 and we're always turning it into an int. And 49.999, when you cast that as an int, that can never be 50. It's just going to truncate the decimal portion. So it's going to be an integer. So yeah, this is going to return any integer from 0 to 49. So we got 0, 0 again, 0 again. So clearly we did something wrong, and it looks like it's because, order operations, we have parentheses right here. If we take int to just Math.random, which is just 0 to 0.999, it's going to truncate the decimal. It's always going to be 0. So that's why you want to do the int portion last. So let's put this in parentheses. So it's going to multiply by 50, then it's going to turn it into an int. So get 40, 4, 28, 43, 48, 18. So yeah, any random number from 0 to 49. It can be a pain to test out all the values. I'm not going to do that. I just know that it happens to go from 0 to 49. But what if I want to, not increase the range, but move the range? So instead of 0 to 49, I want 1 to 50, like I originally wanted. Well, that's easy. After turning it into an int, or even before turning it into an int, you just add 1. So plus 1. And, we're not going to notice the difference immediately. Not unless I get a 50, which is probably not going to happen. Given my luck. I think I used it all today. But yeah, essentially this would modify the range from 0 to 49 to 1 to 50. And this is basically how you come up with random numbers in Java. And without practice, it can actually be very difficult. So let's look at another example. Let's say instead of 1 through 50, we want a random integer from 10 to 34. Now, how can we do that? That's definitely a lot more specific. Well, first thing you want to determine is how many numbers are there between 10 to 34? If you subtract 34 and 10, you get 24. But that doesn't include one of the numbers, because 10 plus 24 would be 34, but we also want to have the number 10 in there. So the range is going to be one more than that value. Range is going to be 25. And what that means is that we're going to multiply Math.random by 25. And when we multiply it by 25, and when we cast that into an int, all that's really going to do is make our number from 0 to 24. But we want it from 10 to 35. So, that part's easy. All we do is just add by 10. And now, when we add by 10, we're taking the range of 0 to 24, add it by 10, and now we get 10 to 34. And again, it's not really that reflective right here, because, random values suck to test, but we got 10 at least, and we got 33, which is close enough, I'd say. So that's how you come up with a range. Find the difference between, the two numbers that are your bounds, add it by 1, and then add like the whole thing by whatever your starting value is. And it would be easy, but if you want to only do even numbers or only do odd numbers, that's when things get even harder. So let's get into that. What if I want all even numbers from 2 to 100? So that's 2, 4, 6, 8, 10, all the way up to 100. No odd numbers. How can I only get even numbers? Well, what's our range? Well, 100 minus 2 is 98, right? 98 is our range, but that's actually not really going to help us here. What we have to think about is how we can always get an even number. And you can get an even number every time if you multiply any integer by 2. But because we're multiplying integer by 2, what that means is we have to come up with a range that's half of what our actual intended range is. So we're going to do Math.random times 50, not 90 something. And once we do it by 50, if I have the int cast, this would give us 0 to 49. Then if I add 1 to it, it would give us 1 to 50. And then if I multiply again the whole thing by 2, if I were to multiply the range of 1 to 50 by 2, I'd get the range of 2 to 100. And not only am I getting the range of 2 to 100, but I'm also making sure that every number printed is going to be even. So we got 38, 20, 4, 8, 70, 8, 94. We didn't get a single odd number out of that. But what if I do want an odd number from, say, 1 to 99? Well, to get an odd number every time, what you do is you take an integer, multiply it by 2, and then after that, you add it by 1. So this is going to work pretty similar to our last method. So I'm going to multiply by 50, but now we're going to multiply this by 2 first, and then we're going to add it by 1. you want to make sure you add by 1 after multiplying by 2 if you want odd numbers. So now this should give us a random number from 1 to 99, and they should all be odd. So 91, 31, 43, 81, 49, 97. These are all odd numbers. What if I want multiples of 5 only of a certain range? So say multiples of a 5 from 5 to 100. Well, instead of multiplying numbers by 2, we're going to be multiplying them by 5. But again, we're going to have to account for that fact that your range is going to have to, account for that by being smaller. So if I want 5 to 100, the range is going to be only about 20 numbers, I think. So 20. And then we want to add the whole thing by 1 because, our starting number is 5. And if we multiply our starting number, if it's 0 by 5, it's still going to be 0. So if we add it by 1, starting number is 1. And then if we multiply the whole thing by 5, starting number is now going to be 5. And because we multiplied our range by 20 and then added by 1, this should help give us multiples of 5 from 5 to 100. So times 20 plus 1 times 5. If I print it out, I got 100, pretty lucky. 95, 40, 25, 90, 65, 55. Only multiples of 5. And what if I want, multiples of 3 from 3 to 24? That one's a little hard, probably because we're not dealing with easy numbers. But let's think about it. 3 to 24, right? And if we want only multiples of 3, well, we know that we're going to have to multiply by 3 in the end. But what's going to be our range? That's the hard part. Well, 3 to 24. How many numbers of 3 are there in that range? Let's think about this. So we have 3, 6, 9, 12, 15, 18, 21, 24. So that's 8 numbers. Yeah, that's 8 numbers. So we're going to actually multiply this by 9. And the reason we're multiplying it by 9 is because we had the int, and that's just going to truncate the 8.999 to just 8. So multiply that by 9. And then multiply it by 3, I believe should work. But let's test it out. So we got 9, 21, 15, 15, 6, 21. So I'd say it's reasonable to assume that this works. So there you have it. That's all the work that has to go into determining these random ranges. It can be really annoying sometimes, but you may notice that we can modify these values however we want. Like if I go back to these ABS methods, I can put like whole expressions in them. So I can put like -5 minus 10 in the first one, which turns into -15, and then the absolute value of that would be 15. And that's the cool thing about coding. Like when you're dealing with methods, you can just put like whole numerical expressions in them, like if you think it makes sense, and the code is going to work. So that's going to do it for this video. We covered modulus operators, wrapper classes, and the math class. In the next video, we're going to go over Boolean expressions, which are huge for Java and huge for any coding language in general. So I'll see you guys there. Bruh, why is this here? How do I get rid of this?